Okay, everyone, here's our last part of section 3.3. And with this particular problem, this is where we put it all together from section 3.1, 3.2, and section 3.3. We are going to graph equations in this form. Or y equals k plus a cosine of bx plus c. Now, this k, of course, is our vertical translation. C is our horizontal translation, if you remember. Okay, so let's think back to what we know. Okay, so let's go ahead and let's do y equals 10 minus 20 sine of 3x minus pi. Okay. And you actually don't need those outer parentheses around the sign. I put them just for my usage. Alright, so what is our amplitude here? Well, this is going to be the absolute value of negative 20, which is 20. Okay? Well, what is our period? Well, this is where, again, we have to take our bx plus c. Now, this is sine, so it's going to equal to 0 and 2 pi. So we're going to take 3x minus pi, set it equal to 0, 3x minus pi equals 2 pi. Okay, so add pi to both sides, so we get 3x equals pi, or x equals pi over 3, and 2. Alright, so add pi to both sides again. That's going to be 3x equals 3 pi, or x equals pi. Okay, so now think about what this is. We solved it all the way out, but we got to be careful about this, because what is my period here? Well, it's kind of hard to see. Remember what I told you earlier. Don't go ahead and subtract all this out yet. We need to leave it separated. So really what you should have done with this is you should have written it as 3x equals 2 pi plus, pi plus 2 pi. Remember, 2 pi always goes second because that's where our period's going to be. Then divide each of them by 3, and so that's pi over 3 plus 2 pi over 3, which equals pi. Okay, this gets us back to this answer right here. Okay, this right here gets us back to this answer right there. Okay, now why did I leave it? Remember, I told you this earlier. Leave it separate like this. Why did I tell you to leave it separate? Remember, this first part right here and right here tells you the phase shift. So we know that our phase shift is pi over 3. We know that our period here is this. Remember, this is why we leave it separated, because the period is that second number there. That's why we always leave 2 pi second, because that's going to give us our period, remember. So I always leave 2 pi as the second number there. So like when we added this pi to both sides, notice I added it to the front. I didn't add it behind 2 pi. I added it to the front. We're doing that so we keep our period second, okay? Keep the period second. So our period is 2 pi over 3. Alright, well, what is this pi over 3 to pi then? What is this right here? Remember, this is the length of one cycle. That's the length of one cycle. So this right here is the length of one cycle. Okay, length of one cycle. Alright, now we have the amplitude, we have the period, we have the phase shift, how far it's shifting horizontally. We also have a vertical shift here. That vertical shift is going to be what? That vertical shift is going to be 10, because K is 10. So that means our x-axis, remember, will be shifted up 10 units. Okay, so we'll graph our graph, and then we'll shift it up 10 units to get the graph of our final answer. So I'm going to show you how I would do this problem. Okay, this is a little different than what I showed you in section um, 3.2 when we dealt with the K. Go back and watch it. I'm going to show you another method here so that you have two to work with. But make sure all this is down. We're going to go to the next page to actually do the graphing. So again, we have an amplitude of 20. We have a phase shift of pi over 3, a vertical shift of 10, a period of 2 pi over 3. Now, what is the increment? Remember, increment is period divided by 4. So that's going to be 2 pi over 3 divided by 4, which is 2 pi over 12, which is pi over 6. So my increment is pi over 6. Alright, so this is the equation we have. Minus the sine, or minus 20 times the sine of 3x minus pi. Okay, so at this point, alright, here's what I want us to graph first. I want us to graph just this part right here. Okay, so let's get all the expenditures of this. Alright, so let's go ahead and make our graph. And we know from what we have solved that one cycle is pi over 3 to pi. But that's one cycle. So we know we're going to have to go there. So this is 0, pi over 3. And then this is 0, pi over 3, 2 pi over 3, 3 pi over 3. And so that's going to be that pi over 3 to pi is going to be our first interval there, our first cycle. Now, what if I told you I wanted to go to, what if I told you I wanted to go another cycle? We'll get to that here in a minute. So let's look at our T-chart. So, we're starting with pi over 3. And our increment is pi over 6. So, we're going to take pi over 3 plus pi over 6. So get you a common denominator there, which is pi over 3 is the same thing as 2 pi over 6. 2 pi over 6. So that's going to give us a 3 pi over 6, which simplifies to pi over 2. So pi over 2 is going to be my second point. All right, well, pi over 2 plus pi over 6. Pi over 2 plus pi over 6. All right, well, that's going to be, at this point, folks, that's going to be, get your common denominator. Pi over 2 is the same thing as 3 pi over 6, plus 1 pi over 6 is 4 pi over 6. So that's the same thing. 4 pi over 6 is the same thing as 2 pi over 3. 2 pi over 3 plus pi over 6. Well, 2 pi over 3, we just said, is 4 pi over 6. Plus pi over 6 is going to be 5 pi over 6. And then plus pi over 6 again gets us back to pi. So that gets us where we want to be. So what we actually need in here, okay, we actually need a couple of more marks. We need pi over 2, and we need 5 pi over 6. 5 pi over 6. So we actually need those two marks there, okay? So let's plug these in and find our point. So plugging them in, we have pi over 3 plugged in for x gives us pi minus pi, which is 0. So the sign of 0 is 0. So negative 20 times 0 is going to be 0. Now remember, we're not graphing it with the 10 yet. We're just graphing this part right here. Okay, this is all we're graphing right now. We're going to do the vertical translation in a minute. Okay, so pi over 2, plug it in. So that's 3 pi over 2 minus pi. Well, 3 pi over 2 minus pi, punch that out in your calculator. That's going to be the same, after you get a common denominator, that's going to be 3 pi over 2 minus 2 pi over 2, which is just pi over 2. So what's the sign of pi over 2? The sign of pi over 2 is 1. The sign of pi over 2 is 1. So negative 20 times 1 is negative 20. Now I'm not writing all this out. I'm verbally saying it because I don't have enough room to write it out here. What you're going to need to be doing is taking these values for x, plugging them back in, finding your common denominator of the things in parentheses, then taking the sign of it. Hopefully that makes sense to you. All right, 2 pi over 3. Plug it in. Well, the 3's are going to cancel, so that's going to be 2 pi minus pi, which is pi. And the sign of pi is 0. 0 times negative 20 is 0. Now, hopefully, you know your sine function. If not, go ahead and plug 5 pi over 6 in. And what you're going to come up with when you do that is positive 20, because 3 times 5 pi over 6 is 15 pi over 6, minus 6 pi over 6, which is pi, gives you a 9 pi over 6, which is 3 pi over 2. Now this is a lot. This is jumbling it up just coming out of my mouth. The best thing for you is to take 5 pi over 6, plug it in, get the common denominator, subtract it, then take the sign of it. That's what I'm doing verbally, remember. But in order for you to see it, I'm going to need you to do that part because of the room I don't have on here. So subtract that out. And so what we have is this. You would get positive 20 after all that. And when you take pi and plug it back in, you're going to get 0. Now this follows the pattern of sine of your original sine function. So you could have gotten this if you knew the pattern of your original sine function. Now the only difference, in the original sine function, this number here is positive and this number here is negative. Why are those reversed? Does anybody know? Hopefully you are screaming at your screen. It's because of the negative sign in front of the 20. The negative sign in front of the 20 has flipped our graph. So that's why that's a negative number first, then a positive number. The original sine function would have been positive, then negative, okay? So keep that in mind. Our graph is flipped. So we'll just say that this is 20. And this is negative 20. Okay, so go ahead. Pi over 3 is 0. Okay, and then we have pi over 2, negative 20. We have 2 pi over 3, 0. We have 5 pi over 6, 20. And then we have pi 0. Now, this is what it looks like. Okay. Now, at this point, what if I asked you with this problem? This is one cycle. Okay. What if I asked you for 2 cycles or 3 cycles? Let's start small, and once you get the drift of the small, you'll be able to go up. So suppose I asked you for 3 cycles. Well, you could extend this graph 2 cycles. If I asked you for 2 cycles, extend this graph on down, and we start here at pi, and we add the increment. Add pi over 6 to it. So that's going to give me 7 pi over 6. Okay? That's going to give me 7 pi over 6. Then add the increment again. That's going to give me 7 pi over 6 plus pi over 6 is 8 pi over 6, which is the same thing as 4 pi over 3. Add pi over 6 again. And once you add pi over 6 again, that's 8 pi over 6. 4 pi over 3 is the same thing as 8 pi over 6 plus pi over 6. I just got a common denominator so I could get the very next one. Add pi over 6 again. That's going to give me 9 pi over 6, which is 3 pi over 2. And finally, because remember, counting this number here, we should have 5 values. See how we have 5 yellow ones? We started here at pi, so we should have 5 values. So this will be our last value in our second cycle. And so add pi over 6 again. Now this is 9 pi over 6. 3 pi over 2 is 9 pi over 6. So 9 pi over 6. Add pi over 6 again. There's a lot of fraction work in here. Get used to that. That's going to be part of it. You got to be able to get the common denominator. So use your calculator to help you get these very quickly so it doesn't take you as long as it's taking me on here. So that's going to be 10 pi over 6. 10 pi over 6, which is the same thing as 5 pi over 3. Now, you do need to check yourself because we started at pi and we ended at 5 pi over 3. Our period, if you remember, should be 2 pi over 3. So you need to subtract these two. Subtract 5 pi over 3 and pi, which if you get a common denominator would be 3 pi over 3. And you're going to get 2 pi over 3. So that is the right values, and that's the right cycle there. You always can subtract the beginning of your cycle and the end of your cycle that I've got arrowed right there, and you should get your period if you've done this correctly. That tells you whether or not you've done your cycles correctly, okay? So you're going to need to watch this video several times, I'm sure, to get the hang of this. And practice, practice, practice. All right, because we're going to be graphing these on the exam, remember. All right, so plug these in the original function. Back up here in what we were doing. This right here, you can plug them in. And following the pattern, when you plug 7 pi over 6 in, you should get negative 20 if you follow the pattern. 0, then you should get positive 20, 0. Following the pattern. See, I didn't have to really work any of that out here. All right, so let me extend my graph. So that's going to be 7 pi over 6. I know that's hard to read. That's 7 pi over 6. That's going to be 4 pi over 3. Make sure you space your graph out a little more than I have. I just don't have much room on the screen. This is going to be 3 pi over 2. And this is going to be 5 pi over 3. All right, so go ahead and plot. 7 pi over 6 is going to be down at negative 20. And then 4 pi over 3 is back up here at the x-axis. 3 pi over 2 is at 20. And then we're back down to the axis again. So it should look something like this. Now what if I asked you for a third cycle? You would extend it on farther to the right. Or you could go to the left. Now how would we go to the left? Instead of adding pi over 6 like we've done here, you could start back at the original up here at pi over 3. Notice I'm circling pi over 3. You could start there, and you could subtract pi over 6 from pi over 3, and it would help you go back in the other direction if you wanted to do that. Now, unless I specifically ask you to go in the negative direction, I would keep it positive. Positive is going to be a lot easier for you. So unless I and if I specifically ask you to go in the negative direction, it won't say give me 2 cycles. If I say in the directions give me 2 cycles, you can keep them all positive. If I want you to be in the negative direction, I will set the cycle for you. I will say from negative pi to negative 8 pi or something like that. I will set it for you so you know where your graph is going from, okay? So, now, we have not finished this. I know you're thinking, gosh, Mr. Francis, come on now. We've not finished this. We just graphed this right here. We still have this vertical shift of 10. So after you graph the original graph here, you're going to need to shift it up 10. So, take each point. This is the point. I'm going to look at my y-axis over here, and I'm going to shift it up 10. So I'm going to add 10 to each of these values. I'm adding 10. Negative 20 plus 10 is negative 10. Adding 10. See what I'm doing there? Now, I didn't do this I didn't do it with a T-chart form in the last section when we graphed a vertical shift. We actually set the new axis. If you remember, from this axis, we went up 10, which would be somewhere right in here, and we drew a new x-axis, and we based everything from there. Some of you expressed to me that the new x-axis, and some of the things I noticed you missed, on the new x-axis, you were having trouble going down 20 and up 20 from the new x-axis. You all were doing it from the original, and that's why you were missing the problem. Well, here's an answer to this. Graph the original like we've done here. Graph your new x-axis. Notice we've added the vertical shift to all of our y-coordinates. So just replot your points. Replot your points. So now, this is going to be 30, and this is going to be negative 10. So let's replot our points. So pi over 3, 10 now. Pi over 3, 10. That's the new x-axis. Pi over 3, 10. 10 is the new x-axis. Remember, this is 10 right here. So that's the new x-axis. And I would label it as that. New x-axis. Alright, so pi over 3, 10, that's the new x-axis. Pi over 2, negative 10, so it's going to be right here now. And we have 2 pi over 3, 10, that's on the new x-axis. And then we have 5 pi over 6, 30, that's up here. Shifted that point up 10. The top of our graph, it's just shifted it up 10, notice. That's our vertical shift taking place. Pi 10, that's going to be on the new x-axis. 7 pi over 6, negative 10, that's going to be down here. We've got 4 pi over 3, 10, that's on the new x-axis. And we have 3 pi over 2, 30, so it shifted that top part of our graph up 10. And 5 pi over 3, 10, so that's back on the new x-axis. So here's what our shifted graph should look like. It should look exactly like so. So if you notice, look at our new x-axis, everything is just shifted up 10 units. And there is a very, very good picture of this in your book on page 162. Page 162. Very, very good picture of this, shifted and translated up, and you can see it. They actually have them on separate graphs, so you can maybe be able to see it a little better. But that's how I would go about doing the vertical shift. If you're having trouble with the new x-axis, some of you, like I said, contacted me and let me know that you had trouble with your graphs from that new x-axis. You weren't starting on the new x-axis. You were thinking in terms of the original. Well, if that's going to bother you, then just draw your new x-axis like I did here, and just add 10 to the y coordinates like we did here, and replot your dots. There's no harm in that. And I'm perfectly fine with you drawing both graphs on the same graph like this. And as a matter of fact, I may actually ask you to do that, to draw both graphs and the vertically translated graph on the same graph. So get used to that, okay? So I think this is another method that will help you with this. I think this will aid you in your graphing. I hope it's understandable. Watch this video several times, but more importantly, practice, practice, practice. And if you're wanting problems to practice graphing, okay? If you're wanting some problems to practice your graphing to prepare you for exams, I would do this. I would go to page 168 in your book. 168, and definitely problems 27 through 30. I would also try problems 39 through 42. 39 through 42. Those would be some other good ones to try to graph. Okay? 39 through 42. Okay? That's some to practice graphing, kind of like I gave you in the last section to help prepare you for the midterm and the final. Now, the odd ones are in the back of the book, so I would just do the odd ones. 27 through 30 odds, 39 to 42 odds. If you decide to practice some of the other ones, that's even better, okay? Let me know if you have questions. This is a complicated section, I realize, so make sure you practice, practice, practice. That's the only way you're going to get good at this, okay? Let me know if you have any questions. Y'all have a good day.